This lesson will cover part 2 of chapter 12 of our Algebra 2 Trig summer course. We'll be diving deeper into trigonometry today, first talking about the unit circle and then finding coordinates on the unit circle, trigonometric functions, special angles, and reference angles. So the first vocabulary term is the unit circle, and the unit circle is a circle centered at the origin, which is 0, 0, and has a radius of 1. So if you look down here, we have a unit circle plotted. So remember, our center is at 0, 0, and then the radius all the way around is 1 unit. In a unit circle, the length of the intercepted arc is equal to the radian measure of the essential angle t. So if we're talking about this angle t, it's talking about this arc right here. That's equivalent to this measure of the essential angle. And what we want to focus on today is that we have coordinates, right? So if we have this point right here along the circumference of our unit circle with our central angle t, our point here is xy, but it's important to note that cosine is this distance down here because we have this central angle. Let me zoom in. There we go. So if our radius is 1, our angle here is t, cosine is adjacent over hypotenuse, but since our adjacent over 1 is just itself, we know our cosine is this measurement right here, versus sine is going to be opposite over hypotenuse, and again our hypotenuse is 1, so it's really just this side right here. So it's important to note that x is going to be cosine of our interior angle t, and our y is going to be sine of t. So if we want to rewrite our xy, we can say x comma y, like an ordered pair, is the same as saying cosine of our interior angle t, or theta, comma, sine of our interior angle t, or theta. So we'll be interchanging these. So just know that whatever is next to your cosine, whatever is next to your trig function, the variable here, that's your angle. So most of the time it'll be like an x or a theta. In this case, our diagram is t, so we're going to call it t. So down below, I have a full unit circle drawn out for us. So what this says is that if we have a circle centered at 0, 0 with a radius of 1, meaning that we have radius of 1 all the way around, if we have different angle measurements, so for example, the first one right here is 30 degrees, which is equivalent to pi over 6 radians, this amount is 30 degrees. This point right here is represented by this point right here, which is the square root of 3 over 2, comma 1/2. So just know that all these red marks are our angle measurements given to us in degrees and in radians, the equivalents. And then the coordinates next to them are the coordinates x comma y of those points along the circumference of our unit circle. So we won't have to memorize this in our class, but just know that in pre-calculus and in calculus, you will need to know this entire unit circle by memory. We're not going to dive deeper into how to memorize it in this class. Just know that you will need to use this diagram to solve our problems later on in our class. Let's get into a little bit more. So I want to talk about the trigonometric functions and identities. So like I said before, cosine of theta, our interior angle, is going to be our x. Sine of our interior angle theta is going to be our y. So if we think about the rest of our trig functions and identities, tangent, if you recall, was y over x. So we know it's sine over cosine. Likewise, the reciprocal functions, so secant was 1 over cosine, therefore we can say it's 1 over x. Likewise, cosecant of our interior angle theta is the reciprocal of sine, so because sine is y, cosecant can be written as 1 over y. And then our last one is the cotangent. So cotangent is the reciprocal of tangent. So if we just flip these, we have a ratio. So it's cosine over sine, or x over y. So we're going to be using all of these trig identities and functions to identify what values our problems are asking us to find below. So our first set of problems here is finding coordinates on the unit circle for specified angles. So what we're going to do is just locate that angle on the unit circle, so the diagram above, and then find the coordinates. That's all we're going to do. So what do we have here? So let me find a color. So we wanted to find the terminal point on the unit circle determined by 5 pi over 4 radians. So our job is to find 5 pi over 4 radians on our unit circle and just give the points the ordered pair associated with that angle measurement. So if we scroll up to our unit circle, we want to find 5 pi over 4 radians. So if you notice here, we always go in counterclockwise order. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This is nothing new, right? So just know that we always start over here. And then when we go all the way around our circle, we also end over here. Likewise, it's the same as saying this is 0, but also 360 degrees. We've gone all the way around the circle, or 0 or 2 pi radians. Therefore, half of it would have to be 1 pi or 180 degrees. Everything else kind of falls between those. Okay, now let's talk about 5 pi over 4 radians. 5 pi over 4 radians is just over 1 whole. So we know that if we start here, we know it's past the 1 whole pi mark. So it has to be somewhere down here. So if we look carefully at our radians, 5 pi over 4 is right here. So we want to look at that angle measurement, and we just have to report back this point for our answer. So we know it's negative square root of root 2 over 2, comma, negative square root of 2 over 2. So that will be our answer for our first one. So our point at which the angle 5 pi over 4 terminates or ends on our unit circle is that point, negative square root of 2 over 2, comma, negative square root of 2 over 2. Let's do another one together. So now we want to find the terminal point for the angle 11 pi over 6 radians. So let's think about this one. So 11 pi over 6 is almost 2 wholes, because 2 wholes would be 12 pi over 6. So let's look at where 2 wholes pi's is on our unit circle here. So again, this was 0, but it's also 2 wholes. So 11 pi over 6 has to be really close to that, and it's right here. So we know that 11 pi over 6 now is this angle measurement, and we want to report back this point right here, which is square root of 3 over 2, comma, negative 1/2. So that is our answer for the second one. Square root of 3 over 2, comma, negative 1/2. At this time, please pause the video, attempt example C on your own. You're looking for 3 pi over 2 radians. If you rather convert that to a mixed number, remember that is 1.5 pi. Our second set of problems here, we're going to determine trigonometric functions and special angles and finding exact values for just one of our trig functions. So instead of finding the entire coordinates or the xy on our unit circle, we're just going to find one of those values. So what does that mean? So you see how it asks us to find the exact value of just cosine of 5 pi over 3? So remember, a cosine is equivalent to the x value. So we want to find the x value at the angle 5 pi over 3. So we're going to do the same process. We're going to look for 5 pi over 3 on our unit circle, locate the coordinates, and then just return the x value as our answer. So let's go up to our unit circle and find 5 pi over 3. So 5 pi over 3 we know is over 1 whole pi, which was over here. And if we're looking at our radians, 5 pi over 3 is right here. So I know this is our angle we're looking for. Therefore, the coordinates we want are 1/2, comma, negative square root of 3 over 2. So I always like to write down my coordinates before I do anything else. So I know my coordinates are 1/2, comma, negative square root of 3 over 2. And again, the x value is the cosine value. So we want just the x value to return for our answer. Therefore, our answer is cosine of 5 pi over 3 is equal to our x value of our coordinates, which is 1/2. Now let's do another one. So over here, we want to find now the sine value of 7 pi over 6. So 7 pi over 6 is what we're looking for. So let's look for that angle on our unit circle up above. So now we're looking for 7 pi over 6. So again, that's just over 1 whole pi, because 6 over 6 would be 1 whole. 7 pi over 6 is right here. So we want this angle. The coordinates next to that are right here. So I'm going to write those coordinates down below in our problem. Sorry for all the scrolling. So we want the coordinates negative square root of 3 over 2, comma negative 1/2. And we want the sine value, so we know that y is equal to the sine value. So if we just write this y value of our coordinates, because remember we have x comma y, this is our answer. So we can say that the sine of 7 pi over 6 is equal to negative 1/2. Down below, let's find some reciprocal values here. So we want to find the secant now of this angle. So we want the secant of 7 pi over 4. If applicable, we're going to write undefined. So what does that mean? Well, we're going to do the same process. Let's look for 7 pi over 4 first. So 7 pi over 4, just thinking about that, that's really close to 2 wholes because, again, 2 wholes would be 8 over 4. So let's look for 7 pi over 4 on our unit circle. We're scrolling up. There we go. So 7 pi over 4 is right here. So now we're looking at this coordinates right here. So we have the square root of 2 over 2, comma negative square root 2 over 2. So we're going to write those coordinates on our problem. So we have the coordinates square root of 2 over 2, comma negative square root of 2 over 2. Secant is the reciprocal of cosine, so we know that secant of theta is equivalent to 1 over x, because again, x is cosine. So if we look at our x value, we have rad 2 over 2, and we want to take the reciprocal of this. So what does that mean? We have the secant of 7 pi over 4, which is what we're looking for, is equivalent to 1 over the x value, which is square root of 2 over 2. Again, I'm not a huge fan of complex fractions, so I like to write it as 1 divided by the square root of 2 over 2. And now I can change it to a multiplication problem. So I can change this to multiplication and then take the reciprocal of that to multiply. So if I do that, I have 1 times 2 over rad 2, which gives me 2 over the square root of 2. I cannot have radicals in my denominator. We can't have that. So we need to rationalize by multiplying by the square root of 2 over the square root of 2. Now we can multiply straight across. So we have 2 times the square root of 2 over 2 wholes, and those 2's cancel each other out, so we have our answer of just the square root of 2. Now let's do another one, example E. So we want to find the exact value of cotangent of pi. Pi is the angle we're looking for, which is just 1 pi, so we know that's 180 degrees. So if we go up, just to show you where that is, remember 0's over here, all the way around is 2 pi, therefore halfway around would be 1 pi. So this is the angle we're looking for, and our coordinates are negative 1 comma 0, and that makes sense, right? Because our radius was 1, so that this distance is 1 wholes, but again, on our coordinate plane, negative 1 would be in this direction. So we have negative 1 comma 0. I'm going to scroll back down now, down to here. So we know our coordinates are negative 1 comma 0. Let's think about cotangent. So cotangent is the reciprocal of tangent. If we know that tangent is y over x, we know that cotangent is x over y. Therefore, if we put our x over our y, we have cotangent of pi is negative 1 over 0. And we cannot divide by 0, therefore our answer is undefined. Let's do one more together. So now we have the cosecant of this angle here. So we want the cosecant of 4 pi over 3. So let's look for 4 pi over 3 on the unit circle. Go ahead and scroll up on your own and look for that. You should have found the coordinates of negative 1/2 comma negative rad 3 over 2. So cosecant is the reciprocal of sine. So we have 1 over y as our cosecant value. So if we take the y value, which is right here, and take the reciprocal of that, that is what we want for our cosecant value. So we have the cosecant of 4 pi over 3 is equal to the reciprocal of our y value, which is 1 over negative square root of 3 over 2. Again, I like to write that as the horizontal division, so I have 1 divided by negative square root of 3 over 2. That becomes a multiplication problem. So we have 1 times 2 over negative rad 3. That becomes negative 2 over rad 3. Again, can't have radicals in the denominator. Multiply by rad 3 over rad 3 to rationalize it. So then we get our answer of 2 times the square root of 3 over 3 as our cosecant value. Next, we have another vocabulary term. So we have reference angles. And what are reference angles? Where they are acute angles formed by the terminal side of our angle theta and the x-axis. The reference angle is always positive. So that's really important to note. So we have positive values only. And I have some directions here as to how to find reference angles. But let's just look at this diagram I have drawn over here so you can understand what I'm talking about. So if we have some angle theta, which is drawn in red, the reference angle is the acute angle formed with the x-axis. So we have to think about where the x-axis is. This angle right here is the reference angle. Versus if our theta were to end down here, the nearest x-axis is right here. Versus if our angle were to end over here in quadrant 4, instead of going all the way around, which would be our angle, our reference angle would be from our terminal side to the positive x-axis. So basically we have 3 different cases for finding reference angles. Case 1 is if quadrant 1 is where our terminal side is. So if we end over here, our angle is its own reference angle. We don't need to do anything to it. It's its own reference angle. If our angle is in quadrant 2 or quadrant 3, meaning up here or down here, we're going to subtract 180 degrees or pi from it and take the absolute value because, again, we want positive angles. If we have a terminal side in quadrant 4, meaning we are down here, we would subtract from the whole, so what would be 360 or 2 pi, or you could subtract from 0 technically because we're over here. So if we think about that, if you are given an angle that is negative, meaning you start here and go down rather than starting here and going up for positive, you can find the coterminal angle first and then go through these processes. Or again, you could subtract from 0. So remember that the coterminal angle is just adding 360 or subtracting 360 or 2 pi respectively, depending on where you are. That was from our previous lesson. So let's work through some of these problems here. We're going to find reference angles for the examples below. And we want to find the reference angle first for 195 degrees. So something that I like to do first is kind of sketch out where my angle is. So I like to always kind of very quickly sketch out a coordinate plane and where my angle is. So I know if I start my angle on the positive x-axis, it's always going to start like this. So essentially you could kind of copy and paste that diagram over to every single problem, which I actually am going to do now just to save us some time. So I'm going to just copy and paste it everywhere because I know I'm going to need it. Okay. Let's go back to example A. Okay, so where are we ending? 195 degrees. If you want to look at your unit circle, you absolutely can. We just essentially want to know where this angle terminates, meaning which quadrant are we in? If I start here, that's 0. Halfway around the circle is 180 degrees. Therefore, 195 would have to be like down in this area right here. So it doesn't have to be exact, but I'm going to guess that 195 is somewhere around here. Therefore, this angle, theta, is our 195 degrees. For our reference angle, we just want the acute angle formed with the x-axis, meaning from the x-axis down, this angle is what we want. So because we are in quadrant 3, sorry, this is quadrant 3. There we go. Because we're in quadrant 3, we're going to subtract from 180. So that means we have to take 180 minus our angle given to us, which is 195. That gives us negative 15. take the absolute value of that. Therefore, our reference angle is 15 degrees. Okay, let's do another one together, example C. So now we're given an angle in radians, so we have to think about this one too. So 4/9. 4/9 is just under 1/2, right? Because technically 4.5 would be half of 9. So 1/2 of our 1 whole, so 1 whole would be here. Half of that is up here. Therefore, I know 4π/9 is somewhere in quadrant 1. So if I draw my terminal side over here in quadrant 1, this is where my angle is going to be. Again, quadrant 1, angles are their own reference angles. Therefore, our reference angle is simply 4π/9. Let's do example D together. So now we have a negative angle. So we have negative 13π/12. So again, starting at our starting point, our initial side, instead of going up to create our angle here, we have to go down. So let's think about this negatively. So again, 0, this would be negative 1π. This is just over negative 1 because negative 1 would be negative 12/12, right? So if we know it's just over negative 1, we're somewhere over here. And this is the angle that is given to us. So again, we want to look for the acute angle that's formed with the x-axis, which would be this angle measurement right here. So remember what I said in the beginning is if you are given a negative angle for your theta, you can find the coterminal angle first, or you can simply just subtract from pi because you're kind of thinking, well, I know my reference angle plus pi would have to give me my angle theta here. So really we could just subtract from pi. So we have pi minus our angle here, 13π/12. We have common denominators created, so pi would become 12/12. And I just kind of like write my pi's over on the side, so I'm just focusing on the fractions. So if I subtract, I get negative π/12. Absolute value of that would be my reference angle of π/12. Example E, so now we have 8π/9. So again, if we start positively and go up, this would be half pi, this would be 1 pi, and 8/9 is a little bit under 1 whole because 1 whole again would be 9/9. So we know our angle terminates somewhere over here. It doesn't have to be exact, I just have to get the quadrant essentially. So we know we're in quadrant 2 from our angle of 8π/9. So now we know we can subtract this from pi because of our information right here. So quadrant 2, we're going to subtract from 180 degrees or pi. So if I subtract from 1 pi, we have pi minus 8π/9. Make common denominators, that means we have 9/9 pi minus 8/9 pi. Therefore, we get pi/9 as our reference angle. So now let's talk about our example F. So we have negative 37 degrees. So negative 37 degrees would mean we have to go downwards from our starting point. And then 37 degrees is not far past this really. So we have somewhere over here-ish as our angle. Our reference angle would be the acute angle formed with the x-axis, which would be the same angle, but the positive version. So if we know that this angle is negative 37 degrees and our reference angle is positive, technically we could subtract from 0, which would mean we have 0 minus negative 37, or we just take the absolute value of 37 degrees. Therefore, our reference angle is 37 degrees. Now let's talk about where our quadrants are and what trig functions, there we go, are positive in each quadrant. So if you see here, we have a unit circle that's unlabeled, and we have all of these trig values that are listed in each quadrant. This is all the positive values. So in quadrant 1, let's just start there. Quadrant 1, we have every single trig value. So we know that all are positive here, meaning that if it tells us I want an angle in quadrant 1, so if T is in quadrant 1, we know that every single value that we give for our answers for all of our trig values here have to be positive. In quadrant 2, only sine and its reciprocal cosecant are positive, so sine and its reciprocal cosecant are positive in quadrant 2, meaning that if you have an angle T in quadrant 2, your sine values are the only going to be ones that are positive. Everything else should be negative. In quadrant 3, we have tangent and its reciprocal, which is cotangent, are positive down here. And then in quadrant 4, cosine and its reciprocal secant are positive. The way that I like to remember this is the phrase, all students take calculus. And the reason why we have that acronym is the first letters. So we have all students take calculus. And if we go in order of our quadrants, 1, 2, 3, and 4, we have A for all, S for sine, T for tangent, and C for cosine. So this is just like a cheat sheet way, essentially, of checking your answers or checking your signs for your answers that we'll be solving down below. So just keep this in mind as we're working through the next set of problems. So we are going to find values of trigonometric functions given information about any angle. So what we're going to do first is we have to find the missing side length that's given to us, then find the trig ratios. So we have to find missing side length first and then go through this whole process and find missing ratios. Let's get into example A. So we have -7, 4. It's a point on the terminal side of theta. Okay, so first of all, let's just plot that point there. So if we plot -7, 4, we know it's going to be in quadrant 2. So it's going to look something like this. So if I plot 7, 4 and just make a radius, essentially, so this is just like part of our unit circle. I just want the radius. That's all I care about. I'm going to create a right triangle down to the x-axis. So I know this is a right angle down here. That's all that's given to me so far. I want to find cosine of theta, sine of theta, tangent of theta, secant of theta, cosecant of theta, and cotangent of theta. So basically all 6 of our trig functions of this angle. So the angle I'm talking about is the interior angle of our triangle, which is this one down here. So this will be our theta. And let's label our triangle that we know. So theta, in accordance to theta, this would be the opposite side over here. Our hypotenuse is up here, and our adjacent side is down here. What are those measurements? Well, 7 is our x, so I know it's this distance down here. So I know, let's label this with green. Okay, -7 is down here. Our height is 4. This is technically correct for any single point. So anything along our x-axis is our x value. Anything vertical is our y value. So again, we have to find our missing side length, which is going to be our hypotenuse first. And we use the Pythagorean theorem for that. So that's a squared plus b squared is equal to c squared. Plugging in our a and b, so we have 4 squared plus -7 squared is equal to c squared. Simplifying down, we have 16 plus 49 is equal to c squared. 65 is equal to c squared. Therefore, c is equal to the square root of 65. So I'm going to write that into my diagram here. So I know my hypotenuse is the square root of 65. Okay, that's a little better. All right, so now I want to go through and find all of the trig values of our triangle. So you can kind of just think about it as being this right triangle here. So cosine, we're going to think back to triangle trigonometry, is adjacent over hypotenuse. So if we think about that, we have cosine of theta is adjacent over hypotenuse. So I'm going to go ahead and put my adjacent, which is -7, over my hypotenuse, was the square root of 65. We can't have this square root of 65 in the denominator, so I'm going to go ahead and rationalize that by multiplying by the square root of 65 over the square root of 65. Therefore, we get our answer of -7 rad 65 over 65. So that is our cosine value of this angle theta. Let's do the reciprocal of that now. So we're going to talk about secant. So secant is 1 over cosine, or hypotenuse over adjacent. So the hypotenuse is the square root of 65 over the adjacent side, which is -7. So I'm going to put my negative in the numerator because I can't have negatives in the denominator. And that is our answer. We don't have a square root in the denominator, so that will be our final answer there. Let's move on to sine. So sine is just opposite over hypotenuse. So that's opposite over hypotenuse. So that would be 4 over the square root of 65. Again, we have to rationalize that. So we're going to multiply by rad 65 over rad 65. So we get our final answer of 4 times the square root of 65 over 65. Let's do the reciprocal of that one now. So we're talking about cosecant. So cosecant of theta is 1 over sine. Therefore, if we just flip our ratios, we have the hypotenuse over the opposite. So the hypotenuse is the square root of 65 over the opposite side, which is 4. And that's our final answer there. Next, we have tangent and cotangent. So tangent is opposite over adjacent. So we just have opposite, which is 4 over -7. So I know I can write it as -4/7. And then the last one is cotangent, which is the reciprocal of tangent. So if I just take the reciprocal of this one, I have my answer, which is -7/4. And that's all of our trig values. So go ahead and pause the video at this time, attempt example B on your own. I would highly suggest that drawing some kind of diagram first so you know where your triangle is. Label the sides that you do know, so you know some things of 2 and -7. Find your missing side first, and then you can go ahead and find all 6 of your trig values. Next, we have a couple different types of problems here. Same idea, but now it gives us a specific trig value. So it tells us that we have theta. It's in quadrant 3, and the sine of that angle theta is -4/5. So I know I can draw quadrant 3 and put my, there we go, put my values there. So if I draw quadrant 3 and I know this point down here is my terminal point, I know my interior angle next to my origin is theta. So I know that the opposite side, I'm just going to label my sides now. So my hypotenuse is over here, my adjacent side is up here, and my opposite side is down here. So my opposite side is this one. My hypotenuse is this one, because this is my right angle, if I think about it that way. So sine of my theta is opposite over hypotenuse. So I know it's opposite over hypotenuse. Therefore, I know this side is equal to -4, and this side over here is 5. So if I know my opposite side and my hypotenuse, my only missing side here is my adjacent side, so I can use the Pythagorean theorem to find that. So again, we have a squared plus b squared is equal to c squared. Plugging in my -4 and my 5 respectively, so I have -4 squared plus b squared is equal to 5 squared. You could absolutely just flip these, it doesn't matter, you'll get the same answer. 16 plus b squared is equal to 25, therefore b squared is equal to 9. Therefore, b is equal to technically +3 and -3, but the reason why I have -3 here is because we're in quadrant 3. So if I know I'm going this way along my x-axis, like in a normal coordinate plane, I know I only have negative x values over here. That's why I know my b value has to be negative. Also, according to our All Students Take Calculus, let me scroll up to that really quick. So if we're in quadrant 3, which is what I was talking about down here, the only values that should be positive are tangent and cotangent. Therefore, everything else should be negative, meaning I know now that this has to be negative up here. So -3 is my adjacent side there. So now I can go ahead and find my missing trig values. It already tells me it's giving me sine. So I just need to find the remaining 5 of my trig functions. So let's start with cosine. So cosine is our adjacent, which is -3 over hypotenuse. So that's when we get -3/5. If we think about the secant, which is the reciprocal of that, we have secant is -5/3. Since we know sine, let's think about the cosecant now, because that would be the reciprocal of this. So we have cosecant is the reciprocal of what's given to us, which is -4/5 up here. So I know my answer is -5/4. Tangent is opposite over adjacent. So we have -4 over -3. Therefore, our tangent would be 4/3. And then the cotangent is just the reciprocal of tangent. So that would be 3/4. So again, notice here, again, we're in quadrant 3. According to our all students take calculus link up above, only tangent and cotangent should be positive. Everything else should be negative. Let's do example D. So same process. Now we're in quadrant 2. So we have quadrant 2 drawn here. And we know that our cosine now is -12 over 13. So again, our interior angle here is our theta. This is our right angle. The cosine is the adjacent over the hypotenuse. So I know my adjacent side has to be -12. My hypotenuse has to be 13. Just know that your hypotenuse is always going to be the positive one. That's kind of a trick whenever you're getting a negative value here. It should be either your adjacent or your opposite. All right, we don't know our opposite side, so let's find that one first by using the Pythagorean theorem. So we're going to plug in our values. So we have a squared plus -12 squared is equal to 13 squared. A squared plus 144 is equal to 169. Therefore, a squared is equal to 25. So A has to be 5. So if we're thinking about this, in quadrant 2, all students' sign should be positive. Therefore, this side has to be +5. So if we think about that, now we have all sides of our triangle and we can find the remaining trig functions. So let's start with sine. So sine of theta is opposite over hypotenuse. That was 5/13. The reciprocal of sine is cosecant right here. So the cosecant is 13/5. We're given cosine. So the reciprocal of cosine is secant. So that would be our next one. Secant is 1 over cosine. So that's just -13/12. And then tangent and cotangent are our last two. So tangent is opposite over adjacent. So that would be -5/12. And then the cotangent is the reciprocal of tangent. So we just reciprocate that, which would be -12/5. We're going to do one more together and you'll do the last one on your own. So example E. So now we have a angle theta in quadrant 4. So I'm going to draw quadrant 4. And we want to label that sine of theta is -8/9. So this would be our theta. This is our right angle. Sine is opposite. So it's opposite over hypotenuse. This is our adjacent side. Opposite would have to be the -8. Hypotenuse would have to be the 9. From this, opposite over hypotenuse. So now we define the missing side with our adjacent side. So using the Pythagorean theorem, we have -8 squared plus b squared is equal to 9 squared. 64 plus b squared is equal to 81. Subtract, b squared is equal to 17. Therefore, b is equal to the square root of 17. So now I know that b, or our adjacent side, is the square root of 17. All right, so now we're going to use all of those measurements to find our values here. So we're given sine. Let's find cosine first. So cosine is adjacent over hypotenuse. So I know my cosine of theta is the square root of 17 over 9. If we think about the reciprocal of cosine, the reciprocal of cosine is secant. So the reciprocal of this one. So we have to flip it. So secant is 1 over cosine. So if we just flip this, that's our cosine value. But again, we cannot have the square root in the denominator, so we need to rationalize it by multiplying by the square root of 17 over the square root of 17. Therefore, we have 9 times the square root of 17 over 17 as our secant value. Let's talk about cosecant now. So cosecant is the reciprocal of what's given to us as sine. So we just flip this, we get our cosecant value. So cosecant again, is 1 over sine. So therefore, we have negative 8/9 as our solution. Now we have tangent and cotangent left. So if you are confused as to which order I'm going in, I'm just going in like the reciprocal values. You can absolutely just follow what's given to you here and go in that order too. All right. Tangent was next. So tangent is opposite over adjacent. So we have negative 8 over the square root of 17. Again, we can't have that 17 under the square root in the denominator. So we get negative 8 times the square root of 17 over 17 when we rationalize. And now we can take the reciprocal of this guy for our cotangent. So technically cotangent, this is our tangent value. So if you don't want to reciprocate this, you can reciprocate this to get your cotangent. It's just easier. This is technically equivalent to this, right? So if we just take the reciprocal of this guy from our tangent value, that will give us our cotangent. So cotangent would be the negative square root of 17 over 8. All right, at this time, please pause the video, attempt example E on your own and any other highlighted problems from our notes, and then scroll down, circle your level of understanding, and fill in a point of confusion.